हेलो दोस्तों। आज एक नया रिसर्च पेपर आया जिसमें लिवरेजिंग फाउंडेशन मॉडल वैसा नॉलेज डिस्ट्रीब्यूशंस इन मल्टी ऑब्जेक्ट ट्रैकिंग डिस्टिलिंग DINOv2 फीचर टू फेयर एम मोट यूनिवर्सिटी ऑफ एम्स्टर्डम ने लॉन्च किया है। और इसमें मल्टी ऑब्जेक्ट ट्रैकिंग MOT जैसा अपन अगर कंप्यूटर विजन सड़क पे कार के नंबर प्लेट को डिटेक्ट करने के लिए अगर कंप्यूटर विजन का यूज़ करते हैं तो वहाँ पर सिर्फ सिंगल ऑब्जेक्ट डिटेक्ट होता है, वो भी नंबर प्लेट। लेकिन ये शायद मल्टी ऑब्जेक्ट डिटेक्टिंग के लिए काम आएगा कंप्यूटर विजन। टास्क दैट हैज बीन एम्प्लॉय इन वेरियस ऑफ सेक्टर्स। Some common limit in MOT are very object appearance occur are crowded scene to address those challenges. Machine learning methods have been extremely deployed and leverage a large data set. Sophisticated model and substantial computational resource and due to practice. However, when a recent release of foundation model by prominent AI company, pre-trained models have been trained on a vast data set and resource using state-of-the-art method. This work try to leverage in such a foundation model called DINOv2 through using a knowledge distillations. The proposed method use a teacher-student architecture where DINO ये टीचर स्टूडेंट आर्किटेक्चर क्या होता है ये एक बार देख लेते हैं अपन। Teacher student architecture for knowledge leverage applications. Although deep learning CNN have showing a strong capacity to solve large scale problem many areas. Teacher student architecture and learning object knowledge expression, ये है टीचर स्टूडेंट आर्किटेक्चर फॉर नॉलेज। इसमें लर्निंग ऑब्जेक्ट, नॉलेज फाउंडेशन, टीचर स्टूडेंट आर्किटेक्चर, लर्निंग शेड्यूल और एप्लीकेशन। और फिर लर्निंग ऑब्जेक्ट में नॉलेज डिस्ट्रीब्यूशंस, नॉलेज एक्सप्रेशंस, नॉलेज अडेप्टेशन, मल्टीटास्क लर्निंग। फिर नॉलेज फाउंडेशन में नॉलेज कंस्ट्रक्शन, नॉलेज ऑप्टिमाइजेशन। फिर टीचर स्टूडेंट आर्किटेक्चर सिंगल टीचर रहेगा लेकिन सिंगल टीचर मल्टीपल टीचर्स। लर्निंग शेड्यूल में ऑनलाइन लर्निंग, सेल्फ लर्निंग। फिर उसके बाद एप्लीकेशन में क्लास पर्पस, CV, NLM, स्पीच। फिर उसके बाद रिकॉग्नाइजेशन पर्पस में CV, NLP, स्पीच। फिर उसके बाद जनरलाइज पर्पस में CV, NLP रहेंगे। ये स्टूडेंट आर्किटेक्चर हो गया। ये स्टूडेंट टीचर आर्किटेक्चर DINO टीचर्स एंड FairMOT बैकबोन H2R ये क्या होता है ये भी देख लेते हैं एक बार। HR नेट V2 HR नेट V2 HR नेट V2 टेंसरफ्लो HR नेट ये क्या होता है ये देख लेते हैं। एक convolutional neural network that train on high resolution represent of input data to perform recognized task. High resolution represent lead to strong position sensitive in output feature representation has been student and result imply although the purpose method has so improvement in certain scenario in does not constrain output from the source. Fair मोट मॉडल, ये मॉडल और देख लेते हैं क्या। Over baseline FairMOT model DLA 34 backbone is the pre-trained on the crowd human for 30 epochs with the self-supervised learning approach, then train on शायद ये और इस पे रिसर्च पेपर जो आया है उसके उसके बारे में थोड़ा देख लेते हैं। मल्टी ऑब्जेक्ट एमओटी इज द importance problem in computer vision, which is a wide range of application. Formulating MOT as multitask learning of object detection and re-ID is single network is applying, since it allows joint optimization of the two tasks and enjoys high computation efficiency. And however, we find the two tasks tend to compete with each other, which need to be carefully addressed. In particular, previous work usually treat re-ID as a second task whose accuracy is heavily affected by the primary detection task. As a result, the network is biased to pr- premium primary detection task, which is not fair to re-ID task. To solve problem, we present a simple yet effective approach. Terminate as a fair mode based on anchor free object detection architecture. CenterNet note that it is not a native combination of CenterNet and ReID instance. We present a bunch of detail and design which are crucial to achieve good tracking result by throwing empirical study in the resulting approach. High, achieve high accuracy for both detection and tracking. The approach outperforms the state-of-art method by the large margin on several public data set. The source code and pre-trained model are released. ये हो गया फिर ठीक है. Those finding highlights are potential and limited of applying foundation models in knowledge distribution for MOT. Introduction. Multi-object tracking MOT is a computer vision is a task that is associated with the detecting and tracking of objects within a video sequence. It already has a nuance or real world application such as pose estimation, virtual surveillance behavior analysis. In recent years, there have been many attempts to improve the state of art MOT, focus on overcome common limits such as vary object appearance and on occasions and crowded scenes data associate ID. Switch to address those challenge. Machine learning methods have been extremely deploy and leverage large data set and sophisticated model and substantial computational resource. The method have lead to improvement, however can clash and somewhat with practical limitation. For example, the process of labeling data for training in MOT algorithm in labor leverage instance and costly high quality labeled data sets are initially for training robust model, but the curiosity of high data limited the potential of many machine learning approach. In addition, Ad- advanced MOT algorithm often require substantial computational power of training and real-time interface. This requirement can be prohibitive for many applications, particularly those with limited access to high-end hardware. Recently, several large models are foundation model trained on vast data set extremely resolve. Those have been released by promoted companies such as Meta AI, OpenAI, Google, DeepMind. Those release those models offers opportunity in many real world applications. Give that large model offer more uh, distributive capability can be utilized as pre-trained model for small and specific data sets. However, using a transformer for a small data sets is not entirely straightforward due to the large size of foundation models. Using only a small amount of data negative impact those performance. Some conventional approach to be address those problems are parametrics efficient fine tuning, PEFT, low rank adaptations, LoRa, and adaptive distribution loss and dilution loss or knowledge dilution involve using a foundation model as a teacher and a small model as a student, guided a student to replicate and performance of the teacher. This approach has shown the promise result in various machine learning application. However, application of knowledge delusion in multi-object tracking MOT using foundation model remain unexplored. This research aim to address the scientific gap by investigation potential of DINOv2 and for as the student model, fairy model as a student model more specific and relevant with will be made on whether employed DNOV2 as a teacher model can transfer in supervised frame and embedding to the fairy moto model and thereby enhancing the student performance of public MOT datasets. By exploring this novel application of knowledge distribution in MOT. This research is seeking to contribute to field by providing insight into the effectiveness of the foundation model in improving the performance of a smaller task. Specify model. This lead to main research question on thesis, to what extent can the foundation version model DINOv2 utilize distribution loss improve the performance of the multi-object tracking. The result mode will be tested on a database on the MOT challenge the dance track dataset to support in answering this research question. The following three sub questions are created. How can the know V2 feature embedding can be transferred efficiently to the FAIR MOT model? To what degree does fine-tuning DINOv2 model help improve the result model? How efficiently does the proposed model generalize to the smaller private dataset? In the following section, the related work will be reviewed to estimate the context of this study within the extending latest. Next modality will detail the researcher design and pursuing using to contact this study. The subsequent section will be present the result following by discussion of the finding. Fa- Finally, the conclusion with summary, the key insight and implementation of research related work. In this section, the state of art MOT model will be expand and how they differ from the affirmations method. Additional current application and inner work of the DNOV2 and FairMOT model will be clarify. Finally, the common practice of knowledge distributions will be so current prices. MOT multi-mode object tracking. MOT is a task of localization multiple object, maintaining their identities, tracking their trajectories. Give a input video. Example of input video are pedestrians working on curbs and cars driving on road. Current MOT model are often benchmarked using the MOT 17 and 20 dataset as well as dance track datasets. Two models are score high on the Moto 17 and Moto 20 on dataset ML Smile Track and Spark Track. The Smile Track approach directly address some key challenges in the field of moto such as conclusion, smaller smaller objective and complex scenes such as dancing people. In this algorithm, similar learning model SLM is used to calculate similar between two objects which address the problem of complex scenes in the image slicing. Attention ISI block are the integrated part of the SLM using the image slicing technique combined with attention mechanism for feature extraction, which are the latter used for the smaller match cascade SMC component that is applied to enhance robust object matching across consecutive video frame. The involved approach using by the small tracking algorithm has been help achieve a high score can Motor and Moto 20 database and Spark Track is the multi-object tracking algorithm that performs is scenes decomposition based on the pursued depth approach, and the sparked decomposition is the essential for enhancing the performance of the associated occurrence and target using pursued depth and estimation to obtain and result depths of the tracks for the 2D image and to a depth cascading match and DCM algorithm that use the obstant deep information to convert the density target set and into multiple spark target and subset and performance data occurring on those spark target substance in order from near to for the two core element by foundation of spark tracking which achieve comparable performance to the other state of method on MOT 17 and MOT 20 which mark the MOT RV2 model performs extremely well on the dancer track dataset MOTR to improve up to MOTR end-to-end tracking method by incorporate an extra object detection past method that use end-to-end object tracking method were often out performance by their tracking by detection counterpart due to their poor detection performance. Therefore, MOTRV2 is designed to enhance detection result before utilize MOTR by formulating a query using the additional object detection to generate occurrence purpose provide a detection priority to MOTR, and this modification help with the unbalanced performance between joint learning detection associated task in the MOTR is this is turned and high performance on the dancing track dataset foundation model with the benchmark breakthrough transformer based foundation model of Meta AI and Open AI. uh, Google Deep Mind new door open in the numerous field of AI with computer vision as one of them. In computer vision, transformers have been applied to tasks include image classification, object detection, action and recognition, segmentation to concept that have made transfer models such as powerful tools or self attendance mechanism as pre- pre-training on large corpora following by task specification fine-tuning self-attention parameters and transformers to learn a relationship between the element of sequence. But whenever traditional methods, for example recurrent neural network RNN would have to rely on research processing sequence element can thus only attend to short-term context. Self-attention mechanism can process complete sequence, allow for learning a long-term relationship. Having self-attention as the core element of the transformers and permits for optimize the parallelism, improve implements, allow them to scale to high capacity model and large scale data set, deploy transformers on vast corporation with unlabeled data in self supervised manner, enabling them to learn feature in the data that can be used without fine tuning to achieve performance on downstream task, scaling those processed by the task specification model to leverage the potential of a transfer model. It can be fine tuning for a special task. This involve additional training on the small task specification data set, adjust the model parameter for given task. We know V2 is the example of foundation model that the user transform train on image label visual task, image classification, instance retrieval, video understanding, or pixel level visual task, deep estimation segment, and we know V2 original from the self distribution with no label model. Dino and Dino users use a self-supervised method to learn a representation of image and such a teachers and student model to deploy knowledge and distillations. These model use vision transfer variety that similar to NLP transformers learn mm, relation with a image data and student teacher model start of a extra coffee. However, during the training process, they are exposed to the different variant of the small image data. The data used for training in ImageNet dataset without label before an image is used. A couple of automations are created, subdivided into global crop, and more than 50% of the original image is still in the picture. Local crops and smaller parts of image. The teacher model is trained on the global crops, and while the student model is trained on the both global and local crops. The outcome of the teacher model is censored by the computational meaning over the bench. After watching both model output go through the heat map, softmax latency and cross entropy less in calculating to see how similar to model performance a stop gradient SG operates in applied to teachers to prerogation and gradients by through the student. The teacher parameter are updated with the exponential moving average EMF of the student parameter. The afferent example process of cell distillation is visual in the figure. By using the original Dino architecture, iBot and Dino V2 are created and improved on the original Dino model. IBOT uses an approach combine self-supervised learning with online tokens and adaptive learning to tokenize in the input image into visual tokenization direct during the training process. Beside the novel architecture, a new data collection method was deployed with the essential combination in large curated and dataset unconventional data for the web crowded dataset result in LVD142M dataset loss V2 loss 1 V1 soft computing student G data S X soft computing is centraling and teachers figure display the student teacher architecture of Dino models and modify the architecture, and this large data set allow Dino to improve over Dino and distillation knowledge. The concept of distillation knowledge has been increased relevant due to self attain and of the art model become large and heavy more parameter than ever model similar to have this high computational and complexity, and also have large storage requirement. Knowledge distillation is essential. A model comprehensing a technique that the task large model as a student, similar student models, teachers, and optimal parameter setting to student model through distillation loss. And this approach is optimal, which when a resource such as dataset and computational power are limited. Here MOT, another model, MOT model that performs well on the benchmark is the Fairy model. Is at the time most MOT model with would use separate model for object detection, which is detect on object of instant interest in the bounding box in the each frame associated with extract re-identification feature from the image reasoning and corresponding to the each bounding box linked to detection to one of the experiment or tracking, and create a new tracking according to certain metrics, and define on the feature and fair MOT integration both into a single framework allow the model to share feature between detection and re-ID improvement. The efficiency accuracy of the tracking fair MOT is the build on backbone response of extracting feature. Those backbone are pre-trained on data types such as crowd human dataset coco on ImageNet. One of available backbone is H2NET-V2R and network. H2NET-V2R is the adaptation of deep neural network and network DCN that maintain high resolution representations through the whole process. It is the character by the continuous high to low conventional or low resolution streams in the parallel and repeated exchange information across conventional string in the four user stage in the network using the strict conventional high resolution इमेज। और इसमें अब आगे क्या है, methodology अप्रोच इसमें क्या रही है, द फाइन ऑफ द फोकस ऑन दिस रिसर्च इज द क्रिएटेड effective knowledge and distribution pipeline utilize a teacher student model architecture. In this startup teacher model transferring knowledge to the student model is specified DINOv2 model acting as the teacher, which fairy model being a student. DINOv2 is a knowledge of expert frame and extract capability enhance in performance well downstream task without fine-tuning. H2R net V2 backbone of the Fairy Moto model also serve a feature extraction generation। और आगे क्या है, ट्रांसफायरिंग फीचर एम्बेडिंग लॉस फंक्शन, फिर फीचर ट्रांसफॉर्मेशन। ये डाटा सेट है वीनो D2। ये वो था स्टूडेंट मोड ना टीचर मॉडल डीनो फीचर एंड फीचर ट्रांसफर हेड एंड H2R नेट एंड फेरी फीचर ये स्टूडेंट मॉडल डिटेक्ट लॉस एंड आइडेंटिफाई लॉस। फिर उसके बाद नॉलेज डिस्टिलेशन पाइपलाइन, इसमें लॉस फंक्शन 1 - अल्फा डॉट डिस्टिलेशन टी इम्बीड एंड एस इम्बीड और फाइन ट्यूनिंग DINOv2। फिर इसमें DINOv2 की साइज क्या रही है, इसमें DINOv2 हाई परफॉर्मेंस विजुअल विच आर जर्नलाइजेशन। इसके अंदर क्या है, प्राइवेट डाटा सेट एक्सपेरिमेंट सेटअप डाटा रिसोर्स ये डाटा सेट ये लिए मोटो 17 मोटो 20 एंड डांस ट्रैक एंड मोटो 17 मोटो 20 के बारे में भी थोड़ा थोड़ा बताया गया है। फिर डांस ट्रैक के बारे में, डांस ट्रैक मोर रिसेंट मोटो डाटा सेट designed to address some of the limitations of extended dataset by providing new challenge tracking dancing in complex choreographic. Its content 100 videos 40 for training, for 25 validation, 35 for testing। फिश डाटा सेट और लिया गया है। फिर उसके बाद रिसोर्स एक्सपेरिमेंट बेस लाइन प्री प्रोसेसिंग भी की गई है इसके अंदर। फिर उसके बाद एबिलिटी एबिलिटेशन स्टडी टू कंस्ट्रक्ट द optimal knowledge and distillation pipeline is abstract study was conducted to the find most efficient loss and transformation method alpha setting and DINOv2 size if we effectiveness of the different model or evaluation using the motor Satra dataset. The video sequence are cut in half using half of the training and half of the validation. This method is used similar to the Sun ETL. The reason for using fair complete model run fair loss function loss cosine MESC multi-layer alpha fair multi-layer feature optimization alpha size। फिर उसके बाद इवलेशन किया गया है मोटो। इस मोटो वन तो ये इसका फॉर्मूला है। मोटो टी ये होता है मल्टीपल ऑब्जेक्ट ट्रैकिंग प्रिसीजन प्रिसीजन। इसके लिए ये फॉर्मूला IDF1 MT मोस्टली ट्रैक्ड। फिर उसके बाद ML मोस्टली लॉस। फिर ये इसका फॉर्मूला। फिर रिजल्ट आया एब्सोल्यूट एबिलिटेशन स्टडी लॉस फंक्शन इवलेशन फीचर ट्रांसफॉर्मेशन इवलेशन और अल्फा पैरामीट्रिक टर्निंग V2V साइज DINOv2 साइज। फिर इसमें डाटा सेट मेथड कौन कौन सा है बेस लाइन मोटो ये। फिर इनमें देख मोटा मोटा है मोटा होना है। रिजल्ट एल्पिलेशन स्टडी कोसाइन इम्बिल्डिंग लॉस सिंगल लेयर ट्रांसफॉर्मेशन अल्फा 0.5 DINOv2 साइज बेस कंप्लीट डाटा सेट। फिर उसके बाद डिस्कस एब्सोल्यूट स्टडी एफिशिएंसी ऑफ DINOv2 फीचर embedding transfer impact on model size result database लिमिटेशन मॉडल सेटिंग के और मोटो मतलब डाटा सेट में भी लिमिटेशन है। बैकबोन फेरी मॉडल ये शायद टीचर वाला मॉडल था। जर्नल DINOv2 conclusion this work has a focus on addressing the scientific gap of using foundation model through knowledge distillation in multiple object tracking. To answer this three sub question was divided how can DINOv2 feature embedding can be transfer efficiency the fair model to what degree decrease does it fine tuning the V2 ये तीन question based on the method the use in this research it was found that feature embedding was transfer most effectively using cosine embedding loss function a single layer transformation and setting alpha to the base 0.50 previous mention। ठीक है। फिर इसके बाद फीचर वर्क ए फॉलो सेटअप मेथड कैन बी टेस्टेड to make a utilize foundation model through knowledge distillation more relevant if possible it could be applied to better performance model for fairy moto and give it a higher starting performance which would making an improvement over more flexible another method that could be potential improve the application of DINOv2. This task is specify fine tuning as previously mentioned as the possible limitations is that DINOv2 feature don't adjust to the MOT task. Therefore, it could be necessary fine tuning the DINOv2 in order for it to produce more applicable feature of मोटो। आज के लिए इतना ही।